I'm Susabhan Sengupta and I'm going to do the second homework question. So we have been given this question where we have to solve this integral, and we have been given this R as a trapezium with vertices 1, 0, 2, 0, 0, 2 and 0, 1. So to solve this question, let's assume two variables as u and v. Let's take it let's take two variables u and v. So u, let's take two variables u and v, where u is equals to y minus x and v equal to y plus x. If we arrange in some order, in same order, we can write this as, rewrite as x equals to v minus u by 2 and y equal to v plus u by 2. So let's rewrite as we this is the rewrite of this. So if we rewrite this integral again, here we get integral of this r with the Jacobian value of cos u by v to dA, u by v into dA. So now we are these are the two equations. We will put the value of these vertices in the xy to get the value of uv. So if we draw a table x comma y and here u comma v, and these are the equations. Let's rewrite here. So equation was here u equal to y minus x and v equal to y plus x. So first point 1, 0 will 1, 0 here will become minus 1, 1. 2, 0 will become minus 2, 2 brackets. 0, 2 will become 2, 2 and 0, 1 here will become 1, 1. Now let's draw the graph based on these points. So the xy, if we draw the xy, it's 0 here, 0, 1, 2, 1, 2. So first this was the A point, A, B, this was C and this was D. Now matching these points here, we get this trapezium kind of region. Let's shade it, put it R, and same, let's draw it here. Same graph for uv, 0, 1, 2, 1, 2. We get points minus 1, 1. You will draw this also. Minus 1, 1. This point, 2, 2 this point, and minus 2, 2 this point. Let's match these points. This is a straight line. Let's draw it with a straight line, no need of dotted lines. So let's shade this area. We get these two graphs here. So we can here see the value of u. This was x here, this was y, and this was here u, and this was here v. So we can see the limit. We can find the limits from this graph. We can see that the limit of v here can go from 1 to 2. So we can here write the value 1 is less than equal to here 1 is less than equal to v is less than equal to 2. This is very important. This, and now from the figure here, this is AB and this is CD. So here we can see the value of AB, not the value of AB, but here we can see that this line, the y is 0 for this line, for AB. So we can write AB y equal to 0, and we know that y equal to, from this page, from here, y equal to v plus u by 2. Y equal to v plus u by 2 equal to 0. So we can write v equal to minus of u, or u equal to minus of v. And similarly, we can see that with the CD x equal to 0 from the graph. So here we can write, by substituting the value, we can write here equal to 0. So we get v equal to u. So now from this page we can see that we have got the limits of u also. So first we got the limits 1 less than equal to v less than equal to 2, and minus of v less than equal to u less than equal to v. These are the two limits we got, and here we have to find the Jacobian value. Jacobian is just the mod of the partial differentiation of dx comma dy. Sorry, let's rewrite this. Jacobian mod dx comma y, and this will be u comma v. So if we expand this, we have to write the determinant dx del x by del u, and del x by del v, and del y by del u, and del y by del v. So here we have to do this partial differentiation with of these equations. So again writing these equations here, which was v minus u by 2 and y minus v plus u by 2. So if we partially differentiate these two equations, so we get the values here: minus half, and half, which here equals to half. So the value of Jacobian or J equal to half. Now substituting the values we all in the integral that we all have, integral 1 to 2, and here minus of v to v cos u by v into half into du into dx. Now we have to integrate this, and this is quite easy integral. We have simplified it so it becomes easy. Now we have to, this half is a constant, so it will come outside. It's easy. And cos u by v, the integral will be sine of u by v into v into dv. Here it will be not dx, here will be dv du by du into dv, not dx, sorry, my mistake. And here it will be dv. Now now we know v is a constant, so here the limits were v to minus v, so here we get half integral 1 to 2 sine v by v. By putting the limits, we here get sine v by v minus sine minus v by v, which is equals to 1. This is equals to minus 1 into v dv. So here further solving, we get sine 1 minus this v dv. This equals to, this will minus minus will add up here, so you will write here 2 sine 1 v dv. So now this whole part is constant, this whole part becomes constant, so here 2 will cancel, sine 1 by 2 v dv. Now the integral of v, we know that it's v dv is v square by 2, so sine 1 into v square by 2, limits here 1, limits 1 to 2. Now putting the upper limit and lower limit, we here get sine, we here get sine 1 2 square by 2 minus 1 square by 2, which is here equals to, this becomes 4, so it's easy, 3 by 2 sine 1. Hence the question is solved. Thank you for your cooperation.